In the previous video, we have seen how to derive the reflection and transmission coefficient of the oblique incident transverse magnetic waves. Following similar steps, we can derive the reflection and transmission coefficient for the case of transverse electric waves or perpendicular polarization or S polarization. So, in the case of transverse electric fields, the incident electric field would be in y direction, and the magnetic field component has z component and x component. And assuming that the normal direction in the x direction and the plane of incidence is xz direction, so in this case the polarization is perpendicular to the plane of incidence and is transverse with respect to the interface between the two media. By following similar steps, we are going to equate the tangential electric field of the reflected plus the incident plus the reflected to the transmitted. So we are going to the tangential electric field above the interface equal the tangential electric field just below the interface, and similarly the tangential magnetic field above the interface equals the tangential magnetic field below the interface. And it should be noted that here the tangential magnetic field of the incident field is opposite to the tangential magnetic field of the reflected magnetic field. Okay? The mathematics would be the same. So the final result is the reflection coefficient for the transverse electric field or the perpendicular polarization or S polarization is EY10 minus, because the electric field here in y direction, so EY01 minus over EY10 plus, and in this case it would be eta 2s minus eta 1s over eta 2s plus eta 1s, where eta 1s is eta 1 over cosine theta 1, or eta 1 multiplied by 6 theta 1. So unlike the parallel polarization, in the case of parallel polarization, eta 1 parallel, it was eta 1 cosine theta 1. In perpendicular polarization, eta 1s equal eta 1 over cosine theta 1, or eta 1 multiplied by 6 theta 1. Similarly, eta 2s is eta 2 6 theta 2, or eta 2 over cosine theta 2. The transmission coefficient in the case of transverse electric field or S polarization or perpendicular polarization would be the magnitude EY20, the magnitude of the transmitted electric field, over the magnitude of the incident electric field EY10 plus, which equal in this case is 2 multiplied by eta 2s over eta 2s plus eta 1s. And we can note that unlike in the case of parallel polarization, we don't have the term cosine theta 1 over cosine theta 2 here. Alright? Once again, if this TE polarization was normal incident such that theta 1 equals 0, so in this case eta 1s would be eta 1 over cosine 0, so it would be eta 1, and eta 2s would be eta 2 over cosine theta 2. So it would be eta 2. So for the case of normal incidence, we will find that the reflection coefficient gamma would be eta 2 minus eta 1 over eta 2 plus eta 1. And the transmission coefficient is 2 eta 2 over eta 2 plus eta 1, which is the normal relations for the normal incident plane wave. Okay? So once again, we can assume that the case of the normal incidence is a special case of the oblique of the transverse electric oblique incidence when the angle of incidence theta 1 equals 0. Alright? So effectively, both the transverse electric and transverse magnetic will be the same if the angle of incidence is 0, or if the field is normal incidence to the interface. Okay. All right. Now let us have an example. We have a uniform plane wave is incident from air into glass at an angle from normal incidence 30 degrees. So angle of incidence or theta 1 is 30 degrees. Determine the fraction of the incident power that is reflected. Here is talking about the power. So we should find out the electric field square, the incident power that is reflected and transmitted for B polarization, parallel polarization, or S polarization, perpendicular polarization. And the glass has a refractive index N to 1.45, and it is coming from air, so N1 equal 1. Now at the beginning, we are going to apply Snell's law to determine the angle of the transmitted field. Effectively, the reflected field would be 30 degrees. So what will be the angle of the transmitted field? So according to Snell's law, N1 multiplied by sine theta 1 equals N2 multiplied by sine theta 2. And N1 is 1, theta 1 is 30 degrees, N2 is 1.45, theta 2 is the angle of the transmitted field, which is unknown. So by solving this relation, we can obtain theta 2 equals sine minus 1 N1 over N2, 1 over 1.45, multiplied by sine theta 1 sine 30. So by solving this relation, we obtain that the angle of the transmitted angle, or the angle of the transmitted field, would be 20.2 degrees. It should be noted that if I am moving from a material with a small reflective index to a material of higher reflective index, the transmitted angle would be smaller. Right? Now, if I'm talking about the parallel polarization, the reflection coefficient will depend on eta 1b and eta 2b. Eta 1b is eta 1 cosine theta 1, and eta 2b is eta 2 cosine theta 2. So eta 1 would be eta 1, the intrinsic impedance of medium 1, which is free space, so 377 ohm, multiplied by cosine theta 1, cosine 30, so this eta 1 parallel. Now eta 2 parallel is eta naught over n, so 377 over 1.45. This is the intrinsic impedance of medium 2, intrinsic impedance of free space over the reflective index, so this is the intrinsic impedance of medium 2, multiplied by cosine theta 2, so we find eta 2 parallel. Now the reflection coefficient gamma parallel equal eta 2 parallel minus eta 1 parallel over eta 2 parallel plus eta 1 parallel. So by applying the values of eta 2 parallel and eta 1 parallel, we obtain the reflection coefficient is minus 0.144. The amplitude of the reflection coefficient is 0.144 and its phase is pi. This is the value of the reflection coefficient, the value of the electric field to electric field. The value of the reflected power to the incident power is proportional to the electric field squared over electric field squared. So the value of B reflected over B incident, it would be gamma B squared. So by squaring this value, we find out the value of the reflected field to the incident field is 0.021. If this is the value of the reflected field to the incident field, so the value of the transmitted field to the incident field is 1 minus this value, because the power or the incident power either reflected or transmitted. So the transmitted power to the incident power would be 1 minus gamma B squared. Okay, so gamma B squared is 0.021. So the value of transmitted power to the incident power is 0.979, and this is dimensionless because these are ratios. Now, if you are talking about the perpendicular polarization, S polarization, we are going to say that eta 1s is eta 1 630 or 1 over cosine 30. So it is 377 over 0.866. It would be 435 ohms. Eta 2 perpendicular, eta 2s, would be eta 2 over cosine 20.2. Eta 2 is 370 over the refractive index of the medium, so 377 over 1.44 over cosine 20.2, so eta 2 perpendicular or eta 2s would be 277 ohms. Now, the reflection coefficient for perpendicular polarization would be eta 2s minus eta 1s over eta 2s plus eta 1s is minus 0.222. Now, the value of the reflected power to the incident power would be gamma s squared would be 0.049, and the value of the transmitted power to the incident power would be 1 minus gamma s squared would be 0.951. Okay? All right.